Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to go over some example problems, practice problems on balancing chemical equations. So I'm going to apply the steps that I have taught to these problems and show you how it's done. So let's get into this. So first problem, I have some zinc sulfide reacting with oxygen to form zinc oxide and some sulfur. So here you'll notice that sulfur is written as a monatomic instead of S8. So we'll go ahead and balance this equation. So the first thing you want to do is, again, balance metals first before nonmetals. That's usually what you do. So balance metals and then the nonmetals. And then when you're balancing the nonmetals, you want to make sure that you're keeping, in any case, keeping the pure element for last. So you'll notice that you have oxygen here that's by itself. It's just a pure element. It's not part of a molecule. So we can save this for last and balance it when we need to. So first we have zinc. So we'll balance the zinc, make sure we have on both sides. So remember the law of the conservation of mass is what we're applying here. So we should have the same number of atoms on both sides of our equation. So that's what we're shooting for. So here we have one zinc atom, and here we have one zinc atom. That's balanced, nothing to do there. Okay, so that's the only metal we have. So let's work on the nonmetals. So sulfur and oxygen are left. Oxygen we'll save for last. So let's balance sulfur. So we have one sulfur here, and we have one sulfur there. So far, so good. So nothing to do so far. So let's now look at oxygen. We have two oxygen atoms on this side, but we have one oxygen atom on this side. So we need to put a 2 here. Now, the one thing I want to mention again, and I'll keep mentioning it, is once you have your formulas, you don't ever want to change the formula, which means you don't ever want to change the subscripts in your formula. So you never want to change or add subscripts to your formula when you're balancing the equation. You only want to change the coefficients. So you want to put numbers in front of your formulas in order to balance your equation. You do not want to do this. I'll just put a 2 here. Now it's balanced. Well, yeah, but you've just changed the compound and you've changed the reaction. So you don't want to do that. So you only want to put coefficients. So we'll put a 2 here. And so now the oxygens are balanced. I have two oxygens here. 2 times 1 gives me 2. And then I have my two oxygens. 1 coefficient times 2 gives me 2. Okay, so, but now we've unbalanced the zinc. So we got to go back to the zinc. So we have 2 zinc on this side, and we have 1 times 1. So we need 2 on here. So what times 1 gives me 2? Well, that would be 2. So here, now I have my zinc is balanced. So 2 zinc, 2 zinc. My oxygens are still balanced. So that's good. And now we have to look at sulfur, because when I balanced the zinc, I also now changed the sulfur. So now I have 2 sulfur atoms on this side, and I only have 1 on that side. So now I have to put a 2 coefficient here. So now the sulfurs are balanced. So now everything's balanced. I now have a balanced equation. And that's how it's done, ladies and gentlemen. Let's keep going. So for problem number 2, practice problem number 2, again, I have 2 metals. I have copper and silver. So it doesn't matter which one I balance first, but since we have this by itself, we'll balance the silver first. But I have silver over here by itself, so either way, it doesn't matter. So here I have 1 copper, and here I have 1 copper. Okay, that's balanced. Here I have 1 silver, and here I have 1 silver. That's balanced. Now we have this polyatomic ion here. And the great thing about polyatomic ions is usually they stay together in the reaction. So you can count that as one unit. So instead of counting the nitrogens, keeping the nitrogens, oh, that's one, and I have three and three, I can count the thing as a whole. So I have one NO3 here, and I have the NO3 here. It's in parentheses, and that means I have this 2 here. That means I have 2 nitrate ions here. So I have 2 nitrate ions here, but I only have 1 nitrate ion there. So I need to balance the nitrates. So since I have 2 here, I'm going to need 2 here. So the only thing I can do is put the coefficient. So since I have 1 here and I need 2, then the coefficient has to be 2 here. So I'm going to put a 2 coefficient. So now my nitrates are balanced. So 2 times 1 is 2, and then 1 times 2 is 2. But now look, the silver atoms are imbalanced. I have 2 on this side, and I have 1 on that side. So I'm going to have to put a 2 coefficient here. So now it's balanced. So silver is balanced, nitrates are balanced, and the copper is balanced. So that is our balanced equation for number 2. Let's move to number 3. So number 3, we have H3PO4 and we have NaOH. So we have our phosphoric acid reacting with sodium hydroxide, and that's going to give us our sodium phosphate and water. And so let's balance this. So again, we'll balance our metals first. So we have sodium here. We have 3 sodium atoms on this side, and we have 1 on this side. So we'll put a 3 coefficient there. So now I have 3 sodiums, 3 sodiums. So that's balanced. That was the only metal. So let's go ahead and balance the others. So here I have PO4 here, and I have PO4 here. So this, I have 1 of these, and I have 1 of these. So that's balanced. And what about the hydrogen? So I have 3 H's here, 3 hydrogens here, and I have 3 hydroxides here. So these are going to come together, and we have H2 over here. So 3 hydrogens plus the 3 hydrogens here, that's 6, but I only have 2 here. So what times 2 is going to give me 6? So if I had 6 hydrogens, what coefficient would I put in front of here? This times this would give me 6. And if you said 3, you are correct. So here, I need to put a 3. So now 3 times 2 gives me 6. And I have 3 waters here, which makes sense because the 3 hydrogen and the 3 OH both come together to form water, and I have 3 water molecules. But we could balance it, we could double check. So I have 3 hydrogens here, and I have 3 hydrogens here, so that's 6. 3 times 2 is 6. What about the oxygens? So the PO4 oxygens are already accounted for, so I don't need to worry about those. But what about these oxygens? So I have 3 oxygens from my hydroxide, and I have 3 times 1 gives me 3 oxygens here. So this is my balanced equation. So we are now done with number 3. What about number 4? Let's go on to number 4. So here I have my calcium phosphate reacting with sulfuric acid, and that's going to give me calcium sulfate as a precipitate, and I get my phosphoric acid as a product. So let's balance the metals first. So here I have 3 calcium atoms, and here I only have 1. So I'm going to need something as a coefficient. So I'm going to put a 3 here because 3 times 1 gives me 3. So now I have 3 calcium and I have 3 calcium. So calcium is now balanced. That's the only the only one that I need to worry about. The only metal I need to worry about. So now I have this polyatomic ion, this phosphate, and I have a phosphate over here too, so I can balance that. So I have two phosphates here, but I only have one phosphate here. So I need two on this side. So that means I'm going to have to put a 2 coefficient because 2 times 1 gives me 2 phosphates. So now that that's balanced, we can now look at sulfate. The SO4 and SO4 here. So you'll notice that I have one sulfate here, but I have 3 sulfates here because 3 times 1 gives me 3 of those. So now I need 3 on this side. So I'm going to have to put a coefficient 3 there. And so now 3 times one of these gives me 3. So now my sulfates are balanced. So everything's balanced so far except for now the hydrogen. So now I have to check the hydrogens. So I have 3 coefficient multiplied by the 2 subscript. 3 times 2 gives me 6. Here I have a 2. 2 times 3 gives me 6. So the hydrogen is balanced. So this is my balanced equation for number 4. Let's go on to number 5. So 5, this is a combustion reaction. I'm reacting CH4 with oxygen, and I always get carbon dioxide and water for a complete combustion reaction. So here, how do I balance this? Now notice I have oxygen here as a pure element. That means I'm going to save oxygen for last. So I don't have any metals here, so I'm always going to balance the nonmetals that are not hydrogen and oxygen. So normally you leave hydrogen and oxygen to last, and then normally oxygen would be last if it's a pure element by itself. So in this case, we're going to leave oxygen for last. So carbon, I have 1 carbon here, and I have 1 carbon there. So carbon is balanced. Don't need to do anything yet. Next, the only 2 I have left is hydrogen and oxygen. I'm going to leave oxygen last. So here I have 4 hydrogen, but over here I have 2 hydrogen. So I need 4 on this side to balance with 4 here. So what times 2 gives me 4? What coefficient do I need to multiply by 2 to give me 4? That would be 2. So I have now 4 hydrogens, and I have 4 hydrogens. So everything is balanced. My carbon is still balanced. So now I can do oxygen. So here, I have how many oxygens here? I have 2 here, right? So I have 2 here, and I have 2 times 1 is 2. So I have 2 here. So those gives me 4. So I have a total of 4 oxygens on this side, and I have 2 on this side. So what times 2 gives me 4? Well, that would be 2. So now my oxygens are balanced. I have 4 oxygens, I have 2, and 2 is 4. So I am balanced. So now I have my balanced equation for number 5. And finally, number 6. So I have chlorine reacting with sodium bromide. That's going to produce sodium chloride and bromine. So again, notice that I have bromine as a diatomic molecule. I have chlorine as a diatomic molecule. So that is important to remember. Okay, so since chlorine is by itself and I have bromine by itself, I can save those to last. So which one I save for last, it doesn't really matter. So on this case, we'll look at sodium here. So I have 1 sodium, which is our metal. So we'll look at that. So the sodium metal, that's 1 each. So that's balanced. So let's go ahead and try the chlorine. We have 2 chlorine here, and we only have 1 chlorine there. So we could balance this by putting a 2 in front of NaCl. So now I have my 2 chlorine, and I have my 2 chlorine. So the sodium is unbalanced now. So now I have to go back to sodium and balance that. So I have 2 sodium here, and I have 1 there, so I'm going to have to put a 2 in front of the sodium. So the chlorines and the sodiums are now balanced. And finally, I balanced the bromine. So I have 2 times 1 is 2, so I have 2 bromine over here, and I have 1 times 2 is 2 over here. So the bromine is balanced, so this is my balanced equation. So that's how you go about balancing your chemical equations. And just in other videos, I go over more example problems. One of the things to watch out for is usually when you're balancing oxygen or some other element, you might get a fractional coefficient. So maybe I might have had to put 1/2 coefficient there. If you ever get a half coefficient, the easy way to balance the equation or to get rid of the fraction is to multiply by the whole equation by a factor that would get rid of the fraction. So sometimes it's easier to write a fraction in order to balance the equation, and that's okay as long as you get rid of the fraction by multiplying the whole equation by a factor that will get rid of that fraction. So for example, if this was 1/2, let's say for the sake of argument that I needed a fraction there to balance the equation, then what I would do is I would keep that fraction there as long as this was balanced, then all I would do is multiply. I would have to multiply this by 2 to get rid of the fraction. But I can't only multiply this, I got to multiply the whole equation. If I only multiply this by 2, then my equation would be unbalanced and after I had just balanced everything. So to keep the equation balanced and at the same time get rid of this fraction, you multiply the whole equation by 2 to get rid of the fraction and keep the equation balanced. But in this case, we didn't have to do that, so we have a whole number coefficient there, so we didn't need to multiply and get rid of fraction. Okay, so I hope this is helpful. This is how you apply the rules and steps of balancing equations. If you enjoyed this video, if you liked it, if you learned something from it, please do me a favor, hit that like button right there, and also subscribe to my channel. Hit that notification bell so you can be notified by other videos I put out. Put a comment down in the comment section. Let me know what you think. Ask me any questions you have. Thanks for joining me. Have a great day.